Okay, so here we have a spotlight that's on the ground and it shines on a wall that's 12 meters away. And it says that if a man that's 2 meters tall walks from the spotlight towards the building at a speed of 1.6 meters per second, how fast is the length of the shadow on the building decreasing when he's 4 meters from the building? Okay, so let's again draw a good sketch so you can make it clear exactly what's going on, then define your variables and exactly what you're trying to find using derivatives. So let's draw buildings. We got the buildings, the wall of the building. Let's get the ground. And this will be the spotlight. This is the wall of the building. Call this Y, this will be our x-axis, this is our y-axis. Okay, so we have a spotlight that shines on a wall. So it's shining on this wall. That's 12 meters away. So the distance from here to here is 12. And this is a man that's 2 meters tall, walks from the spotlight. So he's walking from here in this direction at a speed of 1.6 meters per second. How fast is the length of the shadow on the building decreasing when he's 4 meters from the building? So 4 meters from the building, about 1/3 the way then. So we'll say that, this will be 4. We'll probably get a little bit more. So let's say about there. 2 meters tall, this will be our man. Very good, all right, there's our man. And this shadow is going to be on here. So like what we can do is draw a triangle to kind of represent, use a ruler. So remember, this is the spotlight's, shining this direction. And the man's shadow is going to be, essentially this point to this point. This whole length will be the shadow. So we're gonna have the length of the shadow be called y. Our man. 2 meters tall, so from here to here, let's label that 2. Okay, so now he's walking towards the building at a speed of 1 meters or 1.6 meters per second. So he's walking to the right. He's walking in this direction. So we'll call that the change in x with respect to t. So dx dt. And since it's to the left, we're going to make it negative 1.6 meters per second. And we want to find how fast the length of the shadow on the building is decreasing. So we want to find dy dt when he's 4 meters from the building. So when x equals 4, now we need to find a value for y. When y equals something, we're going to need to solve for that. Y equals something, and when dx dt is negative 1.6. Okay, so let's find a value for y, and let's find a way to relate x and y, and dx dt and dy dt. So remember, this is the shadow, and as he's coming closer to the wall, this value actually decreases. Dy dt, this gets shorter. So this is our dy dt. This is a shadow. See, it's closer. The shadow gets smaller and smaller until it eventually matches his height once he's off the wall. Now, this is 4 meters. The total distance from the spotlight to the wall is 12. So that means the distance from the man to the spotlight will always be 12 minus x. This will be 12 minus x. X is, remember, the distance that he is from the wall. I should probably leave this 4. I probably should leave it as just 8x so that we don't get confusing, because this 4 is that value is changing. This is our variable. This changes as he's walking towards the wall, and this value changes as well. This gets bigger, this gets smaller. So what we can use is similar triangles to solve this problem. See, what we have is the big triangle. Outline it. Big triangle that outlines, you know, this as the hypotenuse. So this, the big triangle will have this as the shadow length, and the base of this big triangle will always be 12. Now, we have a smaller triangle. Let me try to put it in purple. That's, you know, where the left side is the height of the man. So we got a smaller triangle where this side is 2. This base is 12 minus x. And it's a right triangle. So these two triangles are similar because this purple triangle will always stay within that big blue triangle. I mean, don't actually need the length of the hypotenuse, so don't worry about that. These triangles are similar to one another. And so then the equation that we can set up then would be that we could have y over 12 is equal to 2 over 12 minus x. Then from here, let's just write a linear equation. So we'll have y times 12 minus x equals 24. And then so we got 12y minus xy equals 24. So now we got an equation that relates x and y. And now we just need to differentiate this with respect to t, and then plug in our values for x, y, and dx dt. So let's first solve for y, because then we know exactly what we need to plug in. So since y and x are related by this equation, when x is 4, we'll have that y times 12 minus 4 equals 24, or 8y equals 24, or just y equals 8. So now we know what y needs to be. Or sorry, no, y will be 3. 8y will be 24, so y will be 3. Oops. All right, so let's go ahead now and differentiate this equation. Treat it like an implicit differential equation, is implicit differentiation. So we got 12 dy dt minus, here we're going to use the product rule. So minus dx dt times y plus x times dy dt is equal to 0. Solve for dy dt and plug in your values for x, y, and dx dt from here. So we can have, during the dy dt, you know, it's multiplied by that 12 minus that x. I'll take care of that. So minus dx dt times y equals 0. Now let's plug in our values for x, y, dx, and dt. So keeping it going, we'll get dy dt times 12 minus 4 minus negative 1.6 times 3 equals 0. So we got 8 dy dt. This will be a negative 4.8, adding it. So positive 4.8, negative 4.8 at the right. I'm going to divide both by 8. And we'll get the dy dt will be 0.6 or negative 0.6. So negative 0.6 meters per second. So his shadow is decreasing at a rate of 0.6 meters per second when he's 4 meters from the building. Okay, so I hope that helps.